All right, guys, we are on Unit 5 and we are on day 7, and we're going to do a little bit more graphing with our exponential growth and decay. And like I said in the warm-up, we're going to do some shifts too, and you guys can see a number 1. That +4 at the end is going to indicate a shift up 4. So it says graph the function f of x equals. So we're going to go to our calculators. Okay. Go to y equals, clear it out, and type in parentheses, 1/3. It has to be in parentheses, raised to the x, plus 4. Make sure the +4 is not with the exponent. Okay? And you can hit graph if you want to see a picture, or we can go right to our table and copy down part of it. Okay? So we're going to go ahead and have our x column and our y column down the side here in the margin. And we want to make sure we can pick values that fit. And so I'm looking at -213. I think I can make 13 fit on here. -17, 0.5, 1, and it looks like 4.3 repeating. You can always hover over it to see the full decimal. You can turn them into fractions too, but this is fine for right now. All right, I think that's plenty to give our graph some shape. And the highest number we have to put on there is 13. Okay. And so I don't really think that it matters. We don't have anything to graph in the negative, so we can put it pretty low so we don't have to be careful on where we're counting. So there is where I'm going to put my x-axis. And I don't think it matters with the y. You don't go too many on the positive side, and we don't have too many on the negative side. Okay, and there is our y-axis. All right, and then we're going to go ahead and graph some points. So we're going to graph -2, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right there. Okay, -17, 1, 2, 3, 4, 5, 6, 7, 0, 5, 1, 2, 3, 4, 5, 1, and just a little bit above 4, 2, and really just a little bit above 4. And now I think they're getting a little too small to go ahead. So I'm going to go ahead and use a nice smooth curve. And we have to realize that our asymptote is right there. And you can use a highlighter if you would like, or you can graph it in with a dashed line. But I'm just going to highlight that because that line right there is my asymptote. Okay, and that line is a horizontal line, so it's going to be y equals a number, and it's going through 4. And that's why it's getting really, really close to 4, but not going to touch 4. Okay, I'm going to finish off my other end up here with an arrow, and we can call this f of x if we want to label it. Okay, and so number 1 is done. Part A says what transformation was applied to this graph, to this function, and we're going to go ahead and say a shift up 4. And it says, what will this change in the graph? It's going to change the asymptote, y-m-p-t-o-t-e. Okay. It's going to change the y-intercept. I think that might be all it changes, though. Okay, part B, what is the asymptote of this graph? And we said that it's y equals 4. Part C says, is this an exponential growth or decay? And as I read it from left to right, it is going down. So we're going to say decay. And you can say it's decreasing from left to right. Part D asks us to determine the end behavior as x approaches infinity and as x approaches positive infinity. So we'll say as x approaches positive infinity. Do this one first. Actually, they gave me the negative one, so I should probably do the negative one. On the x-axis, this is where negative infinity would be heading. Right? And so we're going to be looking at this end of the graph, and it is going up, and therefore I'm going to say that f of x is approaching positive infinity. Okay. And we'll do our second one as x approaches positive infinity, which is this end here. They're talking about what this end of the graph is doing, and it is also going down, but it is not going to be going down towards negative infinity. It will be going down and getting closer and closer, or approaching 4, since that's the asymptote. Okay. All right. So this one is finished, and we got one more to do. And in number 2, we got some big numbers here. It says graph 380 times 0.85 raised to the 2x plus 20 over the domain from 0 to 20 on the set of axes, and then determine the end behavior. Okay, so we'll set up our table. They're actually giving us an interval from 0 to 20. That doesn't mean that we have to copy down 20 numbers though. Okay, so in my calculator, in y equals, type in 380, 0.85 raised to the 2x, arrow over, and plus 20. So the plus 20, we know that that's going to shift it up 20. The 380 is actually our y-intercept, which I guess makes sense because if you look at your graph there, it goes up to 400. Okay. And so we're looking from 0 to 20. So if you notice, the graph is L-shaped versus a T-shaped, okay, or an X. And so we're going to go ahead and copy down some values for this one. All right. I think it's okay if we skip some numbers in here. So I'm definitely going to include the endpoints of 0 and what goes with 20 as well. What goes with 0 is 400. So there's the 380 for your y-intercept plus the 20 for the shift up 20. So that's why our y-intercept is 400. Let's skip to 2. At 2, we got 218.36. We can skip to 5 maybe. At 5, we're at 94.8. At 10, maybe we skip to 34.7. And again, you can include any numbers as long as you got a bunch between 0 and 20, including 0 and 20. And you have enough points to give your graph some shape. Okay? And I'm going to skip down to 20, which is 20 and 0.57. Okay, so I'm going to go ahead and graph 0, 400. And I'm going to assume this is going to go to 20. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so we'll graph 2 and 218. So we're going to have to put some more in here. So that's what? 20, 40, 60, 80, 100. 20, 40, 60, 80. This will be 200. 20, 40, 60, 80, 300. 20, 40, 60, 80, 400. Okay, so we're at 218. So since we're going by 20s, it'll be right below there. 5 and 94.8. So this is 80, that's 100, 90 will be somewhere around here. 10 and 34, so 20, 40, so 34 would be somewhere around here. And then 15 and 22.9, so 20, so right here. And if you guys can see, we're getting closer and closer to 20. At 20, I forgot to write down the first number. 20 and 20.57. That makes more sense. Okay, and so we're getting closer and closer to 20, but we're not going to touch 20. 20 is going to be our asymptote. So I'm going to go ahead and take my highlighter and highlight this nice horizontal line. Okay, because right there is where we're at 20, and we're not going to be able to touch 20. So our asymptote would be y equals 20 if they asked. Okay, we're going to finish off connecting our dots here. The nice smooth curve. And what's different about this one is that we are not going to put arrows on it because they asked me to graph over an interval. Okay, from 0 to 20, we want to start at 0 for our x and end at 20 for our x and not go any further. Okay. They're asking about the end behavior as x approaches infinity. So we'll say as x approaches infinity, y is approaching, and positive infinity is on this side, and our y is heading towards reaching a value of 20. All right, so as x approaches infinity, y is heading towards 20. All right, and so that's it. And hopefully now we are okay graphing exponential growth or decay graphs. All right, guys, I'll see you guys in the next day of notes.